Hello, it's me. Okay, moving on. We are recording now. Okay, so let me go back to my unit circle. I posted that unit circle, and I really like that unit circle because it has the degrees, it has the radians, it has the ordered pairs, and it also has negative angles if we go clockwise. So this unit circle has it all. And keep that handy. Now, as I was reviewing the quizzes that you already took, there were two problems that involved the same angle that some of you who may be not watching, but maybe you watch later, some of you in the class had wrong. And it was all about the angle. One question was, what is the ordered pair for the angle -3 pi over 2? So you had to give the ordered pair. Now, I know what happened. -3 pi over 2 is 270 degrees, -270 degrees. So some of you probably went counterclockwise and actually found the ordered pair for the positive angle. But -3 pi over 2 is, you go clockwise, is right here. So the equivalent to the positive angle would be pi over 2. So -3 pi over 2, that means the ordered pair is 0, 1 and not 0, -1. So that was one mistake that I saw. And then another one for the same angle, you were being asked which of the trig functions are undefined for -3 pi over 2. Which of them are undefined? Now we already have the ordered pair, which is 0, 1. Let's write them all down. Oops. The cosine of -3 pi over 2 always represents the x value of your ordered pair. So if my ordered pair x coordinate is 0, then the cosine is 0. The sine of -3 pi over 2 is the y coordinate of the ordered pair from the unit circle, and that gives you 1. So if we had to find the tangent of, let me just write this angle, of -3 pi over 2, that is by definition sine divided by cosine, or y divided by x. Y is 1 and x is 0, so anything over 0 is undefined. So the tangent is one of the trig functions that is undefined at -3 pi over 2. And then the other one is, take a look at the cosine. The cosine has a value of 0, which is actually 0 over 1 if you want to make it a fraction. Therefore, the secant of -3 pi over 2 is the reciprocal of the cosine, which is 1 over 0, and that's also undefined. So the two functions that are undefined for -3 pi over 2 is the tangent and the secant. So some of you had that incorrect, and the ordered pair is 0, 1. Does that make sense? Let's see. Yep. Okay. So, Jessica, did you have any other questions? Not that you had this question. I just wanted to show that.
I have a question, but it's about the test, the exam of 3.3 and 3.4.
You mean 4.3 and 4.
Yeah, 4.3 and 4.4.
You mean the quiz, because I haven't gotten, I did not give you the test yet.
No, the quiz. I'm sorry.
Okay, good. So just for everybody else, I haven't given out any tests yet. It's just quizzes.
Just quiz.
Yeah. Test
So,
is coming next week. Okay, what was your question?
the last question in that quiz, I think it was question number 9. It
Hold
was
on. Let me just, I seem to have written on my quadratic equations here. Okay, go ahead.
so. So the last question, it was an input that you had to put.
Let me see.
What?
Oh yeah, you had to, yeah. You have to, you actually have to type the answer.
Yeah. So the question is that as soon as I submit the quiz, is that graded, or I'm gonna
No,
need to wait to have the final grade?
I have to grade it. It
Oh,
will
okay.
not be graded unless I go in there and actually give you the point if it is correct, or give you 0 points if it is incorrect. So
Okay.
yeah. So if your quiz is 9 out of 10, that doesn't mean that you had one wrong. It just means that one needs to be graded that I haven't looked at, that I'm looking at actually right now.
At mine?
Yeah.
Oh. I wasn't sure about that one. It was a little harder.
Okay, well, let's take a look, because that's definitely something we need to know for tests. So it says a guy wire runs from the ground to a cell tower. The wire is attached to the tower that is 150 feet off the ground. So here's my tower, which is 150 feet. And there goes my wire. Here's my wire. Looks like so. The angle formed between the wire and the ground. So here is my ground, and here's my wire. And the angle that is formed is 43 degrees, like so. How long is the guy wire? So in other words, we're looking at how long is this wire with what is given. Always draw a picture. Whatever you do, draw a picture. So we have to come up, it's a right triangle. We have to come up with some kind of relationship between the angle, the sides. So we need to use some of the 6 trig functions. Well, only one. Here's my angle. So theta is 43 degrees. What side is given? Is the opposite side given or the adjacent side?
The opposite?
The opposite. So maybe we can do something with opposite. We have an opposite side, and we need to find really what's called the hypotenuse. We need to find the length of the guy wire, the yellow line here. So that's the hypotenuse. Opposite over hypotenuse. What kind of trig function has this definition?
Sine.
So the dog's bark, my daughter's coming home. That is the sine of 43 degrees. Okay, now we know what the opposite side is. We have a little tiny dog, but he makes a lot of noise. So over the wire is equal to, let's not call it the wire, let's call it x. No, let's call it, let's call it x. We're looking for x equals the sine of 43 degrees. Now, how do you find x?
I think you do x equal 150 divided to sine of 43.
Well, first of all, we want to get rid of this x, so we're going to multiply both sides by x to clear the denominator. So that's 150 equals x times the sine of 43 degrees. Then, to get x by itself, you divide by the sine of 43 degrees. And you use your calculator at this point, because 43 is not one of our common angles. 150 divided by the sine. Make sure that your calculator is in degree mode. 43, if you round it to 1 decimal, It's 219.9 feet.
Hey,
That's it.
that's
So draw a picture, find the relationship somehow between the angle and our opposite hypotenuse and adjacent side, and use one of the trig functions.
okay.
Okay.
Now
What
I
else? Anything in particular in the book you have a question about?
I have a question about project 2. What are we supposed to do with it?
Say again.
Project 2?
Project 2. What you
Yeah.
supposed to do with it?
Yeah.
You're supposed to do it.
Yeah, I know I'm supposed to do it, but like I don't see any instruction or like anything like what I'm supposed to do.
Well, hold on. Let me look. So you go to Falcon Online. You go to discussions. And then you go to project 2. And let me share that screen with you. So I'm now in discussions project 2, and then you click on it. And hopefully there are some, here you go. There are some instructions. So there's part 1. Part 1 you have to prove. You guys may want to mute yourselves. Go ahead and mute yourselves. There you go. See, that's so for the first part, you have to prove that this one first statement is an odd function, and show that this one is either odd or even. And then for the part 2, there are some true-false questions that you have to explain why they are true or false. Like number 1 says, in each of the 4 quadrants, the signs of the secant function and the sine function are the same. You say this is either true or false, and then you explain why. And which one is greater, 1 degree or 1 radian? And here's another true-false question. So that is part 2. And part 3 is an application where you have to find the angular speed in radians per second. There you go. So you would nicely, you print this out, you work on it, nicely put the answers down, then you can scan it and upload it to your completed assignment, of course. You upload it to the assignments folder where it says project 2. It goes right in here. And that's it. Ali, does that make sense?
Yes, ma'am, it does. Thank you.
Good. Good. So that's how you find the project. Now, I will talk about test 1 on Monday, but I will open test 1, or yeah, I will post it probably on Tuesday or Wednesday. And then if I post it on Wednesday, then you have to turn it in on Thursday. And again, you would print it out, you complete it neatly, write it out, paper, pencil, and then scan it and upload it to the assignment where it says test 1 right here. That will happen next week. You will get your first test because 4.4 is the last section that will be on the first test. 4.1 through 4.4.
How many questions are in the test?
Oh, I don't know yet. I don't know. 35? No, I have no idea. Probably a couple more since you are really doing it at home. I like questions where And there are some in the book I found. Of course, I will not give you the one in the book, but the book has some homework problems that say find the mistake or what did the student do wrong. I like those kind of problems on the test, and you have to explain to me. Like this one here. It will not be on the test, so I'm going to show it to you. Number 74 on page 287. Number 74 says the cosine of 60 degrees is opposite over hypotenuse, and that is equal to 1/2. Is this correct? And if it is correct, circle it. If there's a mistake, find the mistake. Is this correct? There's a lot of things wrong with this statement. What's wrong here? Guys, help me out. The cosine opposite over hypotenuse. Well, first of all, that's wrong. The definition for the cosine is adjacent over hypotenuse. So let me draw a triangle. Here is 30, and here this must be 60 degrees. Now, the relationship in this special triangle is we have this side is 1, the hypotenuse is 2, and this is the square root of 3. So the cosine of 60 degrees, hold on, this doesn't look right to me here. The sine of 30 is 1/2. The cosine of 60 degrees is the cosine of 60 degrees. No, that is right. I think I said it wrong. Adjacent over hypotenuse. So what is the cosine of 60 degrees? Is that really 1/2? Yes or no?
Yep.
Yep. So the only thing that was wrong was adjacent over hypotenuse. Anyway, my triangle is correct too, but these are the kind of questions I like to put on a test. What is wrong? What did the student do wrong? So look at that. I also like questions on a test like number 4.3, where you have to use the trig identities. Like, for example, number 47 on page 285. 285, number 47, it is 1 plus sine of theta times 1 minus sine of theta. And that's equal, supposedly, to the cosine squared of theta. So it says use trig identities to transform the left-hand side into the right-hand side. How would you do that? Let me see if we have nobody else is coming in. Okay. How would you do that? Well, first of all, I would go ahead and I would multiply. 1 times 1 is 1. 1 times negative sine theta is negative sine theta.
Yeah.
That's a plus sine theta. And then we have a minus. Sine times sine is sine squared theta. Now you can clearly see that the sines cancel out. What we have left is 1 minus sine squared of theta equals cosine squared of theta. Now what?
Now, that's it, no?
Well, no, you actually you gotta go one step further, or at least you have to describe or identify how this is equal to cosine squared. Where's this coming from? Which identity are you using? The trig identities are on page 280, and one of the most famous of them all identity is the mother sine squared theta plus cosine squared theta equals 1. That is the identity that you're using here. Now you could bring a plus sine squared theta to the other side. And then you're basically done, because on the left-hand side it says 1. 1 equals cosine squared theta plus sine squared theta, which is exactly this identity here. Forgot the 2. Here you go. Okay, well, let me actually talk a little bit about section 4.4. Since you guys don't have any extra questions, but maybe let me talk a little bit about section 4.4 and then do a couple problems, and that will be it. So section 4.4, so I'm hoping that some people are actually watching it and we don't have to talk about it that much on Monday. So section 4.4 is trigonometric function of any angle. So it's basically, again, very similar to 4.3. Let's just say you have some kind of angle theta here. That's theta. And we have, again, our x and y coordinates. So nothing has changed compared to what we did in 4.3. Now, the only thing that has changed in 4.3, or 4.2 actually, in 4.2, we kind of had the same definitions for sine and cosine, but there we had a radius that was equal to 1. So here was our x, y, and we were strictly looking at the unit circle in 4.2. So the radius is 1. In 4.3 and 4.4, our radius is just r. We do not have the unit circle anymore. This is really for any angle, for any function. So the sine of theta is x, is y divided by r. The cosine of theta is still the x-coordinate of your ordered pair, but this time we're dividing it by r. Tangent of theta is y over x, sine over cosine, and don't you forget it. The secant of theta is the reciprocal of the cosine, so that is r over x. The cotangent of theta is the reciprocal of the tangent, which is x over y, and the cosecant of theta, that is the reciprocal of the sine, which is, in this case, r over y. And kind of, it's all based on the Pythagorean theorem. So if you have your ordered pair and you just extend it and have a right triangle, this would be your x value, and here is your y value. And in this case, because it's in quadrant 2, x would be negative, but that's beside the point. So to find r, we would use the Pythagorean theorem. R is the square root of x squared plus y squared. So in 4.2, we had the unit circle. Our r was 1. That's why we only said the sine of theta is y and the cosine of theta is x, because they were all over 1. Now they are not over 1 anymore, they are over r. So for example, if I look at a problem in the book in 4.4, of course, you gotta be careful. You have to have the correct signs. If I look at, how about number 15 in the book? Number 15 says, the point is on the terminal side of the angle in standard position. Find the exact value of the 5 trig functions, and the point is -5, -2. I say that every single time I teach this class, draw a picture. So we're going to plot the point -5, -2. Know in which quadrant you are going to be. So in this case, we are in quadrant 3. So if I draw my triangle, this would be my radius that I'm about to find. This side is negative, this side is my y value, so -2, and the x value is -5. So this is how this triangle would look like. Let me take this -5 out there, it's confusing. So y is -2 units long, x is -5. Now we have to find r. Pythagorean theorem is r squared, well, actually, -5 squared plus -2 squared equals r squared. So 25 plus 4 in this case equals r squared. 29 equals r squared. That makes the radius the square root of 29. So square root of 29. Here you go. Okay, now let's find the sine of theta. Think about opposite. If this is our angle here, opposite over hypotenuse. That would be, in this case, y is -2 over the square root of 29. Now you have to rationalize this square root of 29 by multiplying both sides by square root of 29, and you come up with -2 square root of 29 all over 29. Here you go. What about the cosine of theta? You write it down, and you can tell me if you got it right. Let me check and make sure they are rationalizing the denominator. I'm pretty sure they are. What number is it? 15, 15? Yes, they are. So -5 right. The cosine is -5 square root of 29 over 29. Yep. What is the tangent of theta? Y over x. So in this case, -2 over -5, which is a positive 2/5. And in quadrant 3, the tangent has to be positive. Now that we have the 3 major trig functions, we can just find the reciprocal. So the cotangent of theta is what?
Square root of 29 over 2 negative.
No, the cotangent is the reciprocal of the tangent.
Oh, it's the cosine. Okay, I thought it was.
Yeah, so that would be 5/2. 5/2. The secant of theta, which is the reciprocal of the cosine, is a negative square root of 29 over 5. And the cosecant is the reciprocal of the sine, which is r square root of 29 divided by -2. So I'm going to put the negative here over 2. Here you go. Now we have all 6 trig functions. So the easiest, at least for me, is always to make a little sketch of what you have given, what is going on. Does that make sense?
Yes.
Now,
Question about one of the questions in 4.4.
okay.
I was doing the question number 101, and I got a little stuck with it.
101, was that a homework problem?
I think so.
Current when 100 watt, oh yeah, it's given by where t is the time in second, approximate the current. Well, 101 has not that much to do with the trig function. It's really more like using the calculator. Let's say the current is I, is 5 times E negative 2t times the sine of t. That is when 100 volts is applied to a circuit is given by. So the model is given where t is the time in seconds after the voltage is applied. Approximate the current at t at 0.7 seconds. So you're going to replace the t with 0.7. And now let me use my calculator and see what's happening. What just happened? Where's my screen? My screen disappeared. Ah! Where is my screen? Here you go. Okay, let's see what my calculator is doing. 5 ln is E -2 times 0.7 sine 0.7.
Is that how you're supposed to do it on my
Hold on. Okay, sine 0.7 times, I think I forgot a 5. Second E -2 times 0.7 times 5. Here you go. Okay, you have to enter it in the calculator. So I don't know what calculator you have. 5. First of all, make sure. Okay. Okay, what you get? Press enter.
I pressed. This is how I got. As you see the other way in mirror, it's 0.015.
No, it's 0.79. Did you change? Did you change your calculator to
radians?
To radians. You need to change your calculator to radians.
It's 0.79.
Yes.
Okay.
Yeah. This this is not in degree. Whenever you kind of have a model, it's always, and we do some more later on in the other chapters, you have to change your calculator into radians. So it's negative 1.4 sine 0.7. It is approximate 0.79 amp. Okay?
Okay.
Cool. Now let me go back to what else is in 4.4. What is really important is, of course, you have to know in which quadrant you're in, and you must know your signs in the individual quadrant. So in the first quadrant, here's Q1, here's Q2, quadrant 3, and quadrant 4. So in the first quadrant, all trig functions, sine, cosine, and tangent, and of course, the reciprocals of all three of them are positive. In quadrant 2, the cosecant and the sine of theta are positive. The rest is negative. So cosine, secant, tangent, and cotangent, they are all negative in quadrant 2. Always know in which quadrant your angle is located. Very important. In quadrant 3, the tangent and the cotangent are positive. The rest is negative. Let me just write sine and cosine and the other reciprocals. They are negative. In quadrant 4, the cosine and the secant, of course, the reciprocal have to be positive. The tangent and the sine and their reciprocals, they are all negative. You must know in which quadrant you are located. So the mnemonic that I learned in school at some point in time, all means for all students, so S stands for sine, take T for tangent, calculus, C for cosine. So this is a mnemonic for just the trig functions that are positive. Very important if you're listening to this. All students take calculus. So there are some problems in the book. Which quadrant am I located? Which quadrant? If the sine of theta is greater than 0 and the cosine of theta is less than 0, which quadrant am I located? The sine is greater than 0 means it's positive, and the cosine is negative. Which quadrant do I find myself in? Well, take a look. In quadrant 1, all of them are positive. Can't be it. In quadrant 2, the sine is positive. Oh, okay, I'm getting warm. And the cosine is negative. Here you go. We are in Q2. Let's try another one. The secant of theta is greater than 0, and the cotangent is less than 0. Which quadrant am I in? Jessica, are you the only one? Did Ali go, or?
No, I'm just listening.
Oh, you're listening. Okay, somebody wants to answer, I can answer it. The secant is greater than 0, meaning positive.
Okay.
And the cotangent is negative. In which of the 4 quadrants is the secant positive, but the cotangent negative?
Into?
No, can't be Q2 because in Q2,
Oh,
the cosine is negative, and the secant for that matter.
Oh, I thought it was close. Okay. So.
One, two,
The secant is the reciprocal of the cosine. So we're either looking for a positive cosine or a positive secant. Where is the cosine positive besides quadrant 1? In Q4.
4. Yeah.
In quadrant 4, the cosine and its reciprocal, which is the secant's positive, and the cotangent's negative. So that would be Q4. Okay, we need to practice that some more because you need to know which quadrant you're located. How about this one? Number 21 in the book says the cosecant of theta is greater than 0 and the tangent is less than 0. Which quadrant am I in?
2.
That is correct. One more for good measures. The sine of theta is less than 0 and the cosine is less than 0. That is number 20 in the book. Which quadrant?
3.
That would be 3. That is correct. Yep.
We get it.
There you go. Yeah, but that is something you need to look at again. That is so important. Because otherwise, you do not know all your signs of all your trig functions, which let's practice that. In the book number 27, let's take a look. Number 20, it says find the exact values of the remaining trig functions. Okay, number 27 says the cotangent of theta is, what is it, -3. And the cosine of theta is greater than 0. This calls for a picture. We got to draw a sketch of this relationship. But before I can draw it, I must know which quadrant I'm in. Which quadrant am I in?
In 2.
Only the sign is positive in quadrant 2. All students take calculus. This is a positive. Cosine theta is greater than.
Okay. So it's, yeah.
All students take calculus. Which quadrant am I in? These letters are the abbreviations for the trig functions: sine, tangent, cosine. So if the cosine is positive, but the cotangent is negative, I can only be in quadrant 4.
Yeah.
Quadrant 4. Okay, so you draw your triangle. Here's our angle that we're looking for. Here's our angle. We're not looking for that angle. We're just looking for quadrant 4. Now, what do I know? I know the cotangent is -3. What is the definition for cotangent? Now, since it's just -3, we can set it over 1.
So we know that they're y is 1 and x is -3.
Right. Cotangent. The definition for the tangent, if we go back up here, is y over x. So the cotangent is x over y. So x in this case, x over y. So x is -3, or we have to see which one we're going to make negative, because depending on our quadrant, x over y. So we have a 3 here and we have a 1. And since we are in quadrant 4, only the y value is negative. Here you go. That is our relationship between adjacent and opposite side. X over y. X is 3, y is -1. Does that make sense?
Yeah, but you need to know the Pythagoras formula for that now?
Say that again, I couldn't hear you.
Do I need to now do the Pythagoras formula?
Yes, yeah, because you got to find the rest of the trig functions. You got to find the sine of theta, you got to find the cosine. We already have the tangent. What is the tangent of theta if the cotangent's given?
So it's
-1/3, right. But we need to know what r is. So we need to use the Pythagorean theorem. R is the square root of 3 squared plus -1 squared. So that is 9 plus 1. So R is the square root of 10. Now we can find the rest of the story.
So sine is -1 over square root of 10.
The sine is -1 over square root of 10, which is negative square root of 10 over 10. So if we know that, we know the secant is negative square root of 10 over 1. What is the cosine?
3 times the root of 10 of 10.
Mm-hmm. And the secant would be the square root of 10 over 3. Here you go. So this is important. You always got to know in which quadrant you are located. Let's maybe try that again. Let's do another one. How about 24? 24 says the cosine of theta is 8 over 17, and we are tangent is less than 0. So if I were you, I would draw a little sketch so I know exactly in which quadrant I'm located. But I can find one other trig function right away. I can find the secant because it's the reciprocal, 17 over 8. Okay.
So it's in quadrant form?
It's again in quadrant 4. You are correct. Here you go. See? It's getting easier already.
Yeah.
So here's my angle, and the cosine is positive in quadrant 4. We have 8, and the hypotenuse is 17.
Okay. So again,
So we need to use the Pythagorean theorem to find the y side. So let's say y is the square root of 17 squared minus 8 squared. In this case, we have to subtract.
yeah.
So 17 squared, I do believe is 289. I could be wrong. 17 squared is indeed 289. minus 64 is 225. So the square root of 225 is 15. And now, once we have our triangle relationship, the rest should be easy.
So sine is 15 over 17.
15 over 17, the cosecant is 17 over 15. The tangent is, now, it is 15, but it's actually negative 15 because we are in quadrant 4. So careful here. What is the tangent?
So isn't our sine and cosecant also negative?
Yes, they are negative. They're both negative, yes.
Oh, it's negative 15 over 8.
15 over 8, and the cotangent of theta is negative 8 over 15. Here you go. Yes. We got 200, the square root of 225 is 15. However, we are in quadrant 4, so we have to give it a negative 15 because the y value in quadrant 4 is negative. That's why it is so important that you make a little sketch. And these are definitely problems that you need to know for the test. What else is in 4.4? In 4.4, reference angles. Reference angles.
Actually, I did have a question about the reference angles.
Okay.
I know that sometimes we kind of, in the reference angle, we kind of completing it to the 180 or 270 or 360, but sometimes we kind of minusing it to the 90 or to the 180, if you understand what I mean.
Let's see. Okay, so reference angle in quadrant 2, we have one here. In quadrant 3, the reference is here. In quadrant 4, it would look like that. And so the reference angle makes up the difference. The reference angle is an angle that is between 0 and 90 degrees. It can't be greater than that. And it goes from the terminal side to the horizontal. So the reference angle is this yellow piece here. Now over here, we have this little piece, and if it's in the 4th quadrant, it's that piece. Maybe
so how do you know, because I see that in quadrant 3, you're kind of measuring the same, like where the angle is already laying, and in the other one, you're completing it to either 180 or 360 degrees.
Yes, now let's take a look if the angle is in quadrant 2. If the angle is in quadrant 2, we need to find the reference angle is like theta prime. Well, what we do is we actually go the entire half a revolution, so that's pi. And when we're subtracting theta from it, that only gives us this little yellow piece, and that is our reference angle. So this is pi minus theta will give us the reference angle. Now in quadrant 3, our theta goes past the 180. So to get the reference angle, we have to say theta, which is the entire angle that is given to us, minus 180. The minus 180 is right here, which means we only have this little piece left, minus 180 or minus pi.
So here, why don't I just do 270 minus angle theta?
Because that's not the horizontal. It always has to go back to the horizontal line. If you use the 270, that, I mean, you could, but that would not be the terminal side. If you just do, what did you want to do? 270 minus?
Minus angle theta.
Minus the angle. But if you do 270 minus the red angle, that only gives you this piece. The reference angle is always with the horizontal line, not with the vertical line.
Okay, now I understood. Okay.
Cool. And in the fourth quadrant, well, in the fourth quadrant, it has to be in connection with the horizontal line. And in the fourth quadrant, we're going to do 2 pi. We're going to do 1 full revolution. And then we are subtracting theta from it. And that will give us the reference angle. We always have to look at the horizontal, not at the vertical. So if...
So that's all my mistake. I wasn't sure.
Yeah. If we have an angle that's 213 degrees, what is the reference angle? So first of all, draw a picture. Know which quadrant you are in. 213 degrees is more than 180, so we are here in quadrant 3. So this would be 213 degrees. Now to find the reference angle, we do what? 213
Minus 180.
minus 180. That is correct, whatever that is. 213. I don't even know whose calculator that is I'm having here. I don't like it. Minus 180 is 33 degrees. What about a radian angle? Let's say 4 pi over 5. What is the reference angle?
That's 225.
4 pi over 5. In which quadrant is this located?
That's in 2.
In quadrant 2. That is correct. So this angle here is 4 pi over 5. We find the reference angle how? Well, we're going to take the entire half revolution, that's pi, and then we're subtracting 4 pi over 5 from it. And we get 4 pi over 4 minus, not 4, I have 4 on my mind, that should be 5. 5 pi over 5, which is 1 pi, minus 4 pi over 5, which is 1 pi over 5. Let me see, I'm looking at the book, see what kind of other reference angle we have. I like another one.
Do we also need to learn that negative reference? Like if you're going down clockwise?
Yes, let's take a look if the angle is negative 120. If the angle is negative 120, in which quadrant are you located? Negative 120 would be somewhere over here. So what is the reference angle?
180 minus 120.
180 minus 120, which is 60 degrees. And this is this piece right here. There you go. Yep. Always remember it goes to the horizontal line. And why we're using reference angle? Because if you have, for example, negative 120 degrees, you can always go back to 60 degrees and you would get the same trig functions. Like, for example, if you have the cosine of, and I'm seeing this example here, 4 pi over 3. Well, if you don't have a unit circle handy, and if you don't have a table handy, you can always use the reference angle to figure out what the value is for the cosine of 4 pi over 3. 4 pi over 3 is in quadrant 3. So my angle is 4 pi over 3. Now to find the reference angle, we do 4 pi over 3 minus 180, so minus 3 pi over 3, which is pi over 3. So now the cosine of 4 pi over 3 is almost the same as the cosine of pi over 3. You just have to remember that in quadrant 3, the cosine is negative. So you're going to get a negative here. Pi over 3 is 60 degrees. See, if I have nothing handy, I have no calculator, I have no unit circle, I make myself a triangle. Pi over 3 is 60 degrees. So here is 30, here is 60, here's 1, 2, square root of 3. So the cosine of 60 degrees of pi over 3 is 1/2. But because we are in quadrant 3, it's negative 1/2. One simple little triangle I can derive everything from. This triangle, I mean, the relationship is always the same. You just have to know in which quadrant the angle is located. Once you know that, let me show you another one. How about 7 pi, oh, that's a different triangle. Let's keep it with 5 pi over 3. Let's say our angle is 5 pi over 3. Which quadrant is that one in?
Three? No, 4.
4. This would be in 4, quadrant 4. So 5 pi over 3. Theta is 5 pi over 3. To find the reference angle, we do 2 pi minus 5 pi over 3. So same denominator is 6 pi over 3 minus 5 pi over 3, which again is pi over 3. So pi over 3, if I want to change it to degrees, is 60 degrees again. Drip, drip, drip. Make my triangle. 30, 60, 1, 2, 3. If you go around counterclockwise, you start with 1, 2, and 3. So then the sine of 5 pi over 3, again, make sure you know in quadrant 4 the sign is negative, is the same as negative sine pi over 3, which is
Negative
5 pi over 3, which is what?
3/2.
Negative square root of 3 over 2. Yep, there you go. So just with this triangle relationship, you can really find all the angles in any kind of quadrant. You just have to know which sign. And of course, the other special angle triangle is the 45 degrees. So 45 is the easiest, or pi over 4,
Yeah.
1 square root of 2. The sine and the cosine are the same for that one. Whew. That really covers 4.4 for the most part. They are just, there's some calculator exercises. And here is, like, for example, one more. Why not? We're having so much fun. This stuff is fun. I could do that all day long. 56 in the book says, what does it say? Evaluate the sine, cosine, and tangent of an angle without a calculator for 300 degrees. 300 degrees, again, is in quadrant 4. So the reference angle is, oh, 60 degrees again. Okay. The reference angle again is 60 degrees, 360 minus 300. So what is the, so if I don't know it, okay, I make my triangle. Here's 30, here's 60, 1, 2, square root of 3. So the sine of 60 degrees is the same, let me write it out. The sine of 300 degrees, because that's the original angle, is the same as negative sine of 60, which is negative square root of 3 over 2. The cosine of 300 degrees in quadrant 4 is positive, so we don't need the negative here. The cosine is the same as the cosine of 60, which is 1/2. And the tangent of 300 degrees is also negative. Negative, what do we have? 60, square root of 3 over 1. But I can't see my sine of the individual trig function if I just look at the triangle. I have to look at the quadrant for the sine, not the sine, the SIGN I'm talking about. All students take calculus, and don't you forget it. These are the positive trig functions. In the first quadrant, all of them are positive. What else? Any other questions?
I just have a question about our first test. When is it gonna be?
Next week.
Next week, okay.
Next week, Monday, I will tell you, like I said actually earlier, so next Monday we're going to get together, we're going to review some things, and then I probably post the test on Tuesday, and it will be due on Wednesday.
Okay.
Yeah.
So Wednesday to finish it.
Wednesday, finish it, and yeah, upload it, and yeah. Yeah, that's way longer than you would have in a class. So
Yeah, for sure.
yeah, yeah. Okay, let's do one more for good measures. In the book, these kind of problems that I like, that's why I go over them. How about number 71? 71 in 4.4 gives you the tangent of theta is 3/2, and it says we are in quadrant 3, and it says you need to find the secant of theta.
Okay. So they're both negative.
You got it. So we first of all draw a little graph. Here you go. We are in quadrant 3, and you are exactly correct. They are both negative. So opposite over adjacent. This would be negative, and this is a -2. That is the relationship what we have here, what's given from the book. We have to find the secant, which is the reciprocal, so we need the hypotenuse. We need this r here. So r is the square root of -3 squared plus -2 squared. So that makes that 9 plus 4. 9 plus 4 is indeed 13. So r is the square root of 13. Okay, we have to find the secant. So what is the secant of theta?
Is 1/x. So if
Well, it's not 1 over x because that's not a unit circle.
right, so it's the square root of 13 over -2.
Square root of 13 over -2. So let's make this whole thing negative. Yeah, where you write the negative, I really don't care. That is correct.
Are we gonna go through 4.5 this Monday? Or only
No. 4.5 is the next test. That's graphing. No, this Monday is actually in the schedule is like a review session. So on Monday in class, I'm gonna review, probably go over the review that is posted in Falcon Online. Let me just show you. If you go to content, content, and you go to homework and handouts, you go to test 1, you see a review right here. I probably will go over these problems.
You still see the whiteboard.
Yeah, I'm gonna, hold on, I'm gonna, something about Teams that you always have to get out and come back in. Here you go. So now you can see it, right?
Yeah.
Okay, these are some review questions for 4.1 and 4.4. And if I can come out, this is like 7A is something strict out of the book. That's what we did earlier. I will probably add a couple problems to this one. But yeah, so we're gonna go over the review on Monday, and then I will post the test.
Are we gonna go through every other question in class?
Yeah, I'm pretty sure we have time to go over these questions.
Okay.
It doesn't take too long. And then the following week we start with 4.5, which is graphing.
Okay.
That's even more fun. I like graphing. Yeah, what you definitely, and people who are listening to this recording, what you definitely should know is how to convert from radians to degrees and vice versa. You should know how to find a reference angle, a coterminal angle. You should know, like number 7. I like those kind of questions. They are in the book. Also the common angles, 30, 60 degrees. Yeah. Find the area of a sector. And like I said, I like questions where I give you a mistake and you have to tell me why there's a mistake, or maybe there isn't. Okay, guys, let me stop this recording. This is way too long. Nobody wants. I hope you watch it all the way to the end. If somebody watches, I can see if you're watching it.